Hello guys, good afternoon to all. How are you all? Is my voice clearly audible to you to all? And also my screen is visible clearly or not? Yes, everything is good. Hello guys. Yes, everything is good. Sure. So it's time to start your class. So in the last class, what we have studied, we have covered how to find the middle term. So in today's class, we'll see, I just gave some glimpse about independent term of terms, how to find the terms which is independent of variable, right? So also I gave one question as your homework. How many of you tried this question? How many of you tried this question, guys, and got the answer? Anyone of you tried these questions and got the answer, guys? Okay. So let's solve this question. So the term independent of x in the expansion of this, where x is not equal to 1. Okay. So we need to find the term independent of x, right? Chalo. So let's start solving this question. Okay. So first, before going through find the term, we must have solved or we must have simplified the given expression. So जो भी expression दिया हुआ है ना, that looks very scary. Okay. So let's make it simple. X plus 1 divided by x to the power 2 by 3 minus x to the power 1 by 3 plus 1 minus x minus 1 upon x minus x square whole to the power 10 it is given, right? 10 it is given. So can you tell me one thing? All of you know what is the formula for AQ plus BQ? All of you know what is the formula for AQ plus BQ? Yeah. Anyone can say? That is, yes, A plus B into A square minus AB plus B square. So it's a formula, it's an algebraic identity, already we know this. So see here, in the given expression, in the denominator, in the first term, in the denominator of the first term, you can observe here, that is, we can write this as x to the power 1 by 3 to the power 2 minus x to the power 1 by 3 into 1 plus 1 square. Yes or no? We can write or not? Is it or not? Yes. So if we'll write this one, so in the denominator, in the numerator, what we can write? We can write this as x to the power 1 by 3 to the power 3 and this 3 1 to the power 3 also, that is AQ plus BQ. So in place of x to the power 1 by 3 whole to the power 3, we can write what we can write, guys? Yes, JNB Karimnagar, actually we are solving a question. We are solving a question in which it is asking to find the term which is independent of x, right? So given expression is like this, okay, and in the denominator of the given expression we are having x to the power 2 by 3, x to the power 1 by 3 plus 1. Okay, so we know what is the formula, what is the identity. AQ plus BQ is A plus B into A square minus AB plus B square. So we are just applying this to simplify this given expression. Okay, so in the denominator of the given expression, first term of the given expression, it is given that x to the power 2 by 3. So x to the power 2 by 3 can be written as x to the power 1 by 3 to the power 2 minus x to the power 1 by 3 into 1 plus 1 square. And also x plus 1 can be written, x can be written as x to the power 1 by 3 whole to the power 3 and plus 1 to the power 3 we can write. So in place of a cube plus b cube or x to the power 1 by 3 to the power 3 plus 1 cube. Okay, we can write this as x to the power 1 by 3 plus 1 into x to the power 1 by 3 a square 1 by 3 to the power 2, that is 2 by 3 plus minus ab, that is x to the power 1 by 3 plus b square, that is 1 square. Yes or no? We can write or not? Yes. And also here we can write, if we'll take common root x from the denominator of the second term of the given expression, then it will be root x minus, if we'll take x as common, root x as common, or x square. It is given that x to the power 1 by 2, sorry, it is 1 by 2. So root x common ले जाएंगे तो ये हो जाएगा 1, right? So root x, if we'll take root x as common, this will be root x minus 1, and in the denominator what we are having, root x square minus 1 square we can write. So this will be, this can be written as root x plus 1 into root x minus 1 also whole to the power 10, right? So you can observe here guys, this term and this term both are same, this both will be cancelled out, and then the second expression of the second term of the given expression also root x minus 1 can be cancelled out together. Yes or no? So what we are having till now, we are having now, just we are having, that is x to the power 1 by 3 plus 1 divided by, sorry, we have nothing in the denominator, minus root x plus 1 by root x whole to the power 10 we are having, right? If we'll take the LCM now, so what will happen? So let's take to the next page. Okay, I'm taking this to the next page. Okay, let's see what we are having. If we'll take the LCM here, this will be root x. So root x to the power 1 by 3 into x to the power 1 by 2 plus root 2x or x to the power 1 by 2 minus root x into root x will be x, and this will be minus root x. Okay, so minus root x will be cancelled out whole to the power 10, and x to the power 1 by 3 into x to the power 1 by 2. So what will happen? 1 by 3 plus 1 by 2, 6, 2 plus 3. So x to the power, this will be x to the power root x, yes. So what will happen? X to the power 1 by 3. Yeah, this will be minus 1. No? Sorry. This will be root x minus 1. So root x will be cancelled out. This will be x to the power 1 by 3 into root x minus 1 upon root x whole to the power 10. Now you can see x to the power 1 by 3 into root x upon root x minus 1 upon root x whole to the power 10. This will be root x cancel out. So what we are having, x to the power 1 by 3 minus x to the power minus 1 by 2 whole to the power 10. Now we have simplified the complex expression into a simple binomial expansion. Yes or no? So given the given binomial expansion is given as very complex, it's looking like as a very complex expression, but we have simplified into it's a very to a very simple binomial expansions. So what we are having now, let's see, we are having now x to the power 1 by 3 minus x to the power minus 1 by 2 whole to the power 10. Okay. So we need to find the term independent of x. That means first we need to find the general term. So what is the general term? Anyone can say what is the formula for general term? That is NCR into x to the power n minus r into y to the power r. So in this case, what will happen? T r plus 1 will be 10 C r x to the power 10 minus r into, sorry. So in place of x, what we are having? X to the power 1 by 3 to the power 10 minus r into y. In place of y, we are having minus x to the power minus 1 by 2 whole to the power r. It is having or not? Yes. So we can say, so minus 1 can be taken as common here. We are taking minus 1 here. Minus 1 into 10 CR. So x to the power, here we are getting x to the power 10 minus r by 3 into x to the power minus r by 2 we are getting. Okay. So minus r by 2. So here we are getting two type of things. You can see these things is constant. Okay. But these expressions, see here, these expressions are including variables. So in the question, it is asking to find the term which is independent of x. That means there should be no x or y. Is that clear to everyone? So we need to find here minus 1 into 10 CR. That constant term we need to find. Okay, we need to find. So how we can make it into a constant term or independent of x? That means this power of x must be 0. This power of x must be, when the exponent or index of x will be 0, then this variable terms, this term becomes 1. Then we are having this minus 1 into 10 CR is as my constant. So that for that only we need to find the value of r. So that means to get the term independent of x, that means we have to make the power of x as 0. That means what we are doing? So 10 x to the power 10 minus r upon 3 plus, when we will multiply minus r by 2. So that means this is the variable term we are having. So this to be 1, this to be 1. So 10 minus r by 3 minus r by 2 must be equal to 0. Yes or no? So by solving this, what we are getting? So we are getting the LCM is 6. So this will be 20 minus 2r minus 3r is equal to 0. Is it or not? So we are getting 20 minus 5r is equal to 0. So 5r we are getting 20 and r we are getting that is 4. Right? So value of r we are getting that is 4. Is it or not? Is it or not? So the term which is independent we got the value of r is 4. So the term which is independent of x, that is tr plus 1. So tr plus 1, that is t4 plus 1, that is t5. The fifth term will be the independent of x when r is equal to 4, will be minus 1 into 10c4. 10cr, in place of r, we need to substitute r. So this is the answer, and the value of this will be minus 1 into 10 factorial upon r factorial into 10 minus r factorial. So this will give you 210. Okay, so the answer will be 210. Is it clear to everyone, guys? Is it clear to everyone? JNV Karimnagar and JNV Anam. This is a very good question. Okay. Maximum time in the examination also from this concept questions are coming. Okay. So the term independent of x in the expansion. Okay. So that is, we got the fifth term. Okay. So always remember, when you got the general term, separate the constant term and separate the variable terms, right? Then what are the variable terms you are getting? What is the variable terms you are getting? Make sure, or make the power of that variable is equal to 0. Equate the power of that variable with 0 and find the value of r. After finding the value of r, just substitute here. You will get the term which is independent of the variable x. Is it clear to everyone, guys? Clear? Chalo. If it is clear to all, let's move to another question. Another very good questions also. All the questions are came in previous questions actually. These are the questions from 2022 mains questions we are discussing. Okay. So in this question, it is asking the term independent of x in the expansion 1 minus x square plus 3x cube into 5 by 2 x cube minus 1 by 5 x square whole to the power 11. Right? Chalo. Okay. Okay. So what is the expansion it is given? It is given, see, how we can solve this question. Okay, first we are taking this expansion. We will try to make it simplified. Okay, so 5 by 2 into x cube minus 1 by 5 x square whole to the power 11. So can you write the expansion of this? Can you write the binomial expansion of this? So what it will be? Summation r is equal to 0 to 11, 11 cr, okay, 11 cr into 5 by 2, sorry, into 5 by 2 x cube whole to the power 11 minus r into minus 1 upon 5x square whole to the power r. Right? So this is the binomial expansion. Is it or not? This is the binomial expansion of the given binomial. Okay. So now what we'll do? We'll do little more simplifications also. So let's write summation r is equal to 0 to 11, 11 cr. We can write this as 5 to the power 11 minus r upon 2 to the power 11 minus r, and this x cube, x cube, okay, this will be, leave about the variable. What we are doing first, we need to find the term independent of x. So we need to first separate all the constant terms first. So what are the constant terms? Again, here it is available, that is minus 5 to the power r, right? And this x cube whole to the power 11 minus r, that is 33 x cube, x to the power 33 minus 3r upon divided by x to the power 2r. So x to the power 2r, it will be minus 2r. Yes or no? Minus 2r. Is it or not? Right? So now what we are having, let's again simplify. R is equal to 0 to 11, 11 cr, 5 to the power, okay, now see, 5 to the power 11 minus r into minus 5 to the power r. So we can write this as 11 minus 2r upon 2 to the power 11 minus r. Let's multiply minus 1 to the power r here outside of this. Okay, minus 1 to the power r whole into x to the power 33 minus 5r. Is it or not? Okay, now it is simplified. Now it is simplified. But in the question with this binomial expansions also, some cubic expression is multiplied. That is 1 minus x square plus 3x cube. So let's multiply now with the binomial 1 minus x square plus 3x cube. 1 minus x square plus 3x cube whole into minus 1 to the power. Okay, let's write this inside also. Summation r is equal to 0 to 11 minus 1 to the power r, 5 to the power 11 minus 2r upon 2 to the power 11 minus r into x to the power 33 minus 5r. Now what we'll do? We need to find the term independent of x. Okay, so this whole expansion, this whole binomial expansion is multiplied with this cubic expressions also. Now we'll multiply one by one also. Now we will open the bracket. So what we are getting? So let's see. First we'll multiply one by one. So first option, case one or case one to nahi hai. We can write this one. So first we are multiplied with 1. If you multiply with 1 the whole binomial expansions, what we are getting? That is r is equal to 0 to 1 minus 1 to the power r. Oh, we have left with, here also we left with 11cr. Okay, 11cr minus 1 to the power r into 5 to the power 11 minus 2r upon 2 to the power 11 minus 2r into x to the power 33 minus 5r. Right? Okay. When we are multiplied with 1, this expression, we are getting this. Right? We are getting this. Now tell me how we can get, how we'll get the term which is independent of x, right? Which is independent of x. That means to this term to be independent of x. Okay, this whole term to be independent of x, right? So what should you do? We need to make this power 33 minus 5r must be equal to 0. Yes or no? So yes or no? So this, okay, I'm taking this this whole constant as k, right? I'm taking this as k. Okay, this as k, and this total expression to be independent of x. That means this power must be equal to 0. That is 33 minus 5r must be equal to 0. So 5r we are getting 33. So r is equal to, we are getting 33 upon 5, which is not an integer. Okay, which does not belongs to the set of integer. That means in this case we will not get any term which is independent of 0, because r cannot be non-integer. It must be integer, na? So we are getting r is an non-integer. So that's why we can say in this case this term is not free from x, right? This term is not free from x, or there is no term you will get which is free from x, because r cannot be non-integer fraction, right? Then come to the second thing. Then come to the second scenario. Second scenario, it is saying minus x square. Okay, so I'm taking the second scenario, minus x square into, okay, minus x square, or we can say minus x square. Just we can write this way. Okay, minus x square into k into x to the power that is 33 minus 5r, right? K into 33 minus 5r. Okay, so let's think about it. So when we are multiplying x square with this total expression, so this to be 0, this to be independent of x, this to be independent of x, so this x to the power 33 minus 5r must be what? So when we are multiplying x square with x to the power 33 minus 5r, so for what value of 33 minus 5r, or when we are multiplying x square with x to the power 33 minus 5r, it will give 0. It will give you 0. When 33 minus 5r becomes minus 2. Yes or no? When 33 minus 5r becomes minus 2, then if you multiply x square with x to the power minus 2, it will give you 0. It will be 0 or not? Yes. So that means if we'll solve it, we'll get 5r is equal to 33 plus 2, that is 35. So here I am getting r is equal to 7. Yes. So r is equal to 7 we are getting here. Yeah, very good, JNB Karimnagar. Let's solve it. Okay. So here we are getting r is equal to 7. That means the constant, what is the constant term? So k is equal to, here I am getting k is equal to minus of summation summation minus 1 to the power r is 7. Okay, from r is equal to 0 to 11, right? R is equal to 0 to 11. Okay, and 11c7, this na 11c7, 5 to the power 11 minus 2 into 7 upon 2 to the power 11 minus 7. So this is the term we are getting. This is the term we are getting, minus 1. Whole divided by anything we are having. Okay, so this is, so by solving it or calculate this one, you will get 23 by 200. Very good, 23 by 200. So this is the second case, but in the third case, what will happen? If when we'll multiply plus 3x cube, let's see, it is very simple, plus 3x cube, third case, with summation k into x to the power 33 minus 5r. Okay, so similarly here also, this to be independent of the term x, this to be the term independent of x, so 33 minus 5r must be minus 3. So 5r becomes here 36. So r we are getting 36 upon 5, which does not belongs to z. That means there is no term which is free from x. Okay, so what is the answer? So final answer is 23 upon 200 is your answer. This is your answer. 23 upon 200 is your answer. Is it clear to everyone, guys? Zenbi Karimnagar, very good. You got the answer. It's really appreciated and it's very good. You are you given the answer very correctly. Nice. Thank you. Okay. So you have, do you have any doubt in this question? It's a very nice question. Na? Did you have any doubt, guys? You can answer. You can ask in the chat box also. Zenbi Anam, is it clear? Okay, shall I move to the next concept? Okay, let's move to the next concept, that is numerically greatest term. So what is numerically greatest term? Okay, so consider if I'll take one expansion, that is ax plus by whole to the power n, right? So that means what is the general term you will get here? Sorry, what is the general term you will get here? Tr plus 1, that is ncr into ax to the power n minus r into by to the power r. Yes or no? Yes or no? Is it or not? So we can write this as also ncr into a to the power n minus r into x to the power n minus r, or we can write b to the power r into x to the power n minus r into y to the power r. Yes or no? So this is my constant term, this is my constant term, and this is my variable term. Is it or not? Yes. So the total, so we can say in total, so there are three cases arising. We can say these totals are, these are, or sorry, this is the r plus 1th term. So if I'll take the total expression, if I'll ask you what is this, then you can say this is the r plus 1th term, because here you can see na, this is the r plus 1th term. Okay. And secondly, if I'll ask you what is the constant you got here, what is the coefficient of, or sorry, what is the coefficient you got here? If I'll ask you what is the coefficient you got here, so coefficient means you can say, so the coefficient is ncr. Here I will use another color here. Okay, the coefficient will be ncr a to the power n minus r b to the power r is coefficient of x to the power n minus r into y to the power r, right? So this is the coefficient of this. This is the coefficient of this r plus 1th term also, we can say. But the third thing is, what is the binomial coefficients you are getting here? What is the binomial coefficients you are getting here? The binomial coefficient is actually NCR is my binomial coefficient of r plus 1th term. Understood or not? So this is my, remember, this is my binomial coefficients, and this yellow boxed constant is my coefficient of r plus 1th term, and totally we can say this is my r plus 1th term of the expansion. Is that clear to everyone? You can make a note or you can take a screenshot of this slide also. Is that clear to everyone, guys? Now we'll have some more theory, some, you can say, thoda lengthy theory hai. So you have to listen. It might be tough to understand to you, but when you will try to understand the concepts, or when you will try to understand the theory, then it will be easy to evolve, right? So try to understand first. Okay, so these are the concepts which is very clear to all of you or not? Yes or no? Let me know in the chat box, everyone. Yes. Clear. Chalo. So let's move to how we can find numerically greatest term. Okay, so what do we mean by numerically greatest term? Right, suppose I'm writing x plus y to the power n. So this is the binomial expansion having the terms t1 plus t2 plus t3 and so on up to Tn, right? So if I'll ask you to find the numerically greatest term, how we can find numerically greatest term? Okay, so this is the meaning actually. What is the meaning numerically greatest term? Already we have learned one thing when we did find the highest, so maximum binomial coefficient, right? Maximum binomial coefficients. We already studied these things, na? The middle, always the middle term has the maximum highest binomial coefficient. Yes or no? So similarly, here we are going to study or cover how we can find numerically greatest term. So what do you mean by numerically greatest term? Okay, so we'll understand these questions. Don't worry. So previously we made one figure when n is equal to 2, है so when n is equal to 2, we make like this the figure, है this so actually this okay. So when n is equal to 2, that is a plus b to the power square. So this is nc0, this is nc1, this is nc2. When n is equal to 3, nc0, nc1, nc2, nc3, right? So these all these are represents to the my binomial term, binomial coefficients or terms of the binomial expansions, right? Binomial expansions. So similarly, if I'll ask you, if you'll specifically, if you'll give, okay, specifically, if you'll give some values to x and y, if you'll take some specific values of x and y, if you'll take x and y, right? So that means if you'll take values of x and y, we'll fix some values 1. If you'll take x is equal 1, y is equal to 2. So what will happen? Okay, so that means when you will put the value of x and y, you will get some terms. After putting the values of x and y here, you will get some terms there. Those terms are t1, t2, t3 up to tn. So if you'll roughly make the graph of all the terms, constants, if you'll roughly make the graph of all the constants, so this will be like this. Okay, suppose these are my terms. We'll make this थोड़ा उसको अच्छे से बनाना पड़ेगा ना. Okay, suppose these are my terms. Okay, so like okay, so if I'll ask you to find what is the numerically what is the term who is numerically greatest? Numerically greatest means, what do you mean by numerically greatest? So if I'll ask you one thing, minus 30 or minus 30, you can take any number, minus 36 and 30. So which is greater actually? Obviously, you can say, sir, 30 is greater because it is positive and minus 30 is negative. But when we are, which is greater? In between these two numbers, 30 is greater than. So 30 is greater than minus 36. But when we are talking about, when we are discussing about the numerically greatest term, that means we are talking about the absolute value. If we are talking about the absolute values, that means minus modulus of minus 36. It is actually minus 30. The numerical value of minus 36 is greater than the numerical value of 30. Is that clear to everyone? Numerically, minus 30 is greater than 30. Okay. So actually, this is we can say here numerically, I'm making a note, numerically greatest term is actually is the absolute value of the number of the term, we can say. Remember, okay? Okay, is that clear to everyone? Okay, suppose if I'll make this is my T1, this is my T2, this is my T3, and so on. Suppose this term, I'm taking this term. Okay, I'm taking this term T r plus 1, and this term is T r plus 2, and this term is T r. Okay, this term is T r. Similarly, and so on, Tn. Right. So these are my terms. Okay, these are my terms of the expansion x plus y to the power n. Have patience, try to understand. Okay, these are my terms of the expansion x plus y to the power n. We are represented here. Okay, so now you can observe here T r plus 1 is the term which is numerically greatest. Yes or no? This is the term which is numerically greatest term, or NCG we can say, numerically greatest term. Okay, so this is the term which is numerically greatest term. So there may be 2 or 3 terms, those are numerically greatest term. Yes or no? Here we are considering only one case. Okay, TR plus 1 is the numerically greatest term. But there may be the case, two terms will be when we will be having a flat surface, and 2 terms we will be having. Then there will be 2 terms will be numerically greatest also. Right? So similarly, the simple thing is here, if we'll observe here, T r plus 1 or r plus 1 term is the numerically greatest term. So how we can find numerically greatest term? So simply you can say here, you can observe the figure and you can say here, first thing is T r plus 1 is greater than equal to T r plus 2. Yes or no? Okay, we are taking the first case from the left side. T r plus 1 is greater than equal to T r. Yes or no? This is my first case. Or another case, we can say T r plus 1 is greater than equal to also T r plus 2. This is the second case. Yes or no? So these are my 2 cases we need to consider. Right? Is that clear to everyone? T r plus 1 is greater than equal to T r, and T r plus 1 is greater than equal to T r plus 2. That means always remember the numerically greatest term. The numerically greatest term is greater than equal to its immediate right term and also to the immediate left term. Yes or no? See, if Tr plus 1 is the numerically greatest term, it is greater than or equal to its immediate right term. To its immediate right term is Tr plus 2, and also it is greater than equal to its immediate left term, that is Tr. Is it clear or not? Simple. Okay. So now, if we'll consider the first case, just have 5 minutes patience. It is important actually. From these concepts in advanced mains everywhere, you will get kinds of questions. Consider one, that is very simple. This is the theory I am explaining. After this, you will get a very small formula and you can solve the questions very easily. Right? So T r plus 1 is greater than equal to T r. Right? So what is T r plus 1? That is NCR what we have taken the expansion as x plus y to the power n, na? That is x to the power n minus r into y to the power r, which is greater than equal to tr, that is nc r minus 1, and x to the power n minus r plus 1 into y to the power r minus 1. Yes or no? So these are the general term of the given expansion, right? Okay, if we'll open this, if we'll use the formula of combinations here, this will be n factorial upon r factorial into n minus r factorial into x to the power n minus r into y to the power r, which is greater than equal to n factorial upon r minus 1 factorial into n minus r plus 1 factorial, right? Into x to the power n minus r plus 1 into y to the power r minus 1. You can see here, if we'll divide x to the power n minus r on both sides, you will get, in the right hand side of the inequality, you will get x. And if we'll divide y to the power r minus 1 upon on both sides of the inequality, you will get in the y in the left hand side of the inequality, right? So you can see now, it will be cut this with, you will be having here x, and if you will this, then you will be having here y, right? And also see, r minus 1 factorial can be cancelled here, and you will be having r into r factorial can be written as r into r minus 1 factorial. So r minus factorial, r minus 1 factorial will be cancelled out, and you will be having r into, similarly n minus r1 factorial, this can be written as n minus r plus 1 into n minus r factorial, or not? Yes or no? So this will be cancelled out. So you will be having n minus r plus 1. So finally, what you are having here? We are having here n factorial upon r, which is greater than equal to, we forgot to take the modulus actually. Always there are modulus. Remember, always there are modulus. Now we are talking about the numerically greatest value. This in this formula also you are having modulus. We are talking about, or we are discussing about numerically greatest term. That's why. Okay. So here we are getting n factorial upon r into y. And in the right hand side, what we are having? We are having n factorial divided by n minus r plus 1 into x. Yes or no? These you are having. And n factorial will be cancelled out, na? Yes. So finally, what we are having? We are having y upon r, which is greater than equal to x upon n minus r plus 1. Right? Is that clear to everyone? Okay. Now, if we'll cross multiply, okay, if we'll cross multiply here, so what you will getting? You will be getting n minus r plus 1 upon r is greater than equal to mod of x upon y. Yes or no? So we can write this as also, just few minutes. We can write this as also, n plus 1 by r, minus r by r, that is 1, which is greater than equal to mod of x by y, right? So this is equal to, we can write, if we'll take, see here, we know r is always greater than equal to 0 to and less than equal to n, right? So n minus r will be positive, greater than equal to 0. If r is less than equal to n, then n minus r will be greater than equal to 0. That means n minus r plus 1 also be greater than equal to 0. Since we are taking, so this n minus r plus 1 is greater than equal to 0. So we know, we don't need to take the modulus in the left hand side of this inequality because it is positive always. That means we can write this as n plus r by r minus 1. From here also we can erase the modulus because n minus r plus 1 is positive, r is positive, simple. So this is greater than equal to mod of x upon y. Acha. So simplifying, we are getting n plus 1 upon r is greater than equal to 1 plus mod of x by y. Is that or not? So if we'll take the reciprocal of this inequality, we'll get r upon n plus 1 is less than equal to 1 upon 1 plus mod of x by y. Right? Okay? We got this? Okay. Now, simple. Now, if we'll multiply n plus 1 on both sides, what we are getting? So we are getting simply r is less than equal to n plus 1 divided by 1 plus mod of x by y. Okay. So this is my result. This is my result. We got here r, right? We got here r. It's a very nice result actually. When we'll solve question in 2 to 3 tips to solve questions when before understanding these concepts, the questions will be feeling like very difficult questions, but after understanding the concepts, it will be very easy, right? So if we'll take this, if we'll take this term as m, I am taking this as m. Okay, this as m. So similarly, if we'll consider the second, scenario, what is that? Consider the second scenario, which is tr plus 1 is greater than equal to tr plus 2. So if we'll follow the similar process, you will get one result, that will be r will be greater than equal to n plus 1 divided by 1 plus mod of x by y minus 1. You will get this, right? And this is my m, you know. This is my m. Already we have taken this is my m. Okay. So now we can generalize here. We can conclude here if r plus 1th term, is numerically greatest, then what we got? Then r must be greater than equal to m minus 1 and less than equal to m. So this is the inequality we got. This is the result. Okay, this is the very important result we got. What is m here? Where we can write here, where m is equal to n plus 1 upon 1 plus mod of x by y. So this is my m. Okay, so this is the relation to solve the question very easily. Is that clear, everyone? Is that clear to all? So this is the results we got. Where r is less than equal to m minus 1 and less than greater than equal to m minus 1 and less than equal to m. Okay, now important thing is here also two cases are arising. First case, if what is the conclusion we got? Actually we got the conclusion as m minus 1 is less than equal to r is less than equal to m. So this is the result we got, right? So what is the case 1? If m is an m is an integer. So what will happen? If m is an integer, suppose I am taking for example m is equal to 4. Okay, so m is equal to 4. That means r will be 4 minus 1, lying between 3 and 4. So here, if we are getting r is equal to 3, 4, yes or no? So there are two integers you are getting. There are two integers you are getting in between 3 and 4, including 3 and 4. Those are 3 and 4. That means what are the greatest, numerically greatest term? That is t 3 plus 1 and t 4 plus 1. Those are t4 and t5 are numerically greatest terms. Okay, this is the first case. Guys, clear? This is the first case. Is that clear? When m is an integer, suppose I am taking m is equal to 4, then r is lying between 3 and 4. That is because r is greater than equal to m minus 1. So m is 4. So m minus 1 is 3. And it is less than equal to m. That is 4. So in between 3 and 4, where 3 and 4 are included, then r is 3 and 4. So if you are getting r as 3 and 4, then the numerical greatest terms are tr plus 1. Na? When r is 3 and 4, then you are getting t4 and t5 are numerically greatest terms. If we'll consider the second case, okay, if we'll consider the second case also, case 2. So what is the case 2? If m does not belongs to integer, if m is a fraction, suppose I am taking m is equal to 3.5. I am taking, for example, I am taking m is equal to 3.5. So we know m is less than, we know r is greater than equal to m minus 1 and less than equal to m, right? So in this case, r will be 3.5 minus 1, that is greater than equal to 2.5 and less than equal to 3.5. So tell me, in between 2.5 and 3.5, in between 2.5 and 3.5, okay, in between 2.5 and 3.5, so what are the integers you are getting? Only one integers we are getting, that is only one integers we are getting, that is 3, right? So r here, r we are getting 3. So in case of fraction, we'll get r is 3, only one value of r will get, then the numerically greatest term will be, hence the numerically greatest term is tr plus 1, that is t3 plus 1, which is equal to t4. Is it clear? So there are two cases. Remember, the most important thing is when you are asked to find the numerically greatest term, first you need to find m. What is m? What is m? M is n plus 1 upon 1 plus mod of x by y. Remember this, m is n plus 1 upon 1 plus mod of x upon y. So let's solve one question, it will be clear to all. Okay, so let's see here in this question, you need to find the numerically greatest term in the expansion 1 plus 4x to the power 8 when x is equal to 1 by 3. Always when in the question numerically greatest term is asked, always the value of x is will be given, or the value of y will be given, the value of the variable will be given. In the derivations also we took the specific values for the specific values of x and y, right? So see here, if x is equal to 1 by 3, first we need to find m, right? So what is m here? M is n plus 1 divided by 1 plus mod of x by y, right? So n is given as 8 plus 1, that is 1 plus mod of x. Mod of x is 4 into x is given as 1 by 3, right? Divided by y. From where I will get y? Sorry. sorry, what is x here? X is 1, no? Sorry, 1 upon y. 1 upon y is 4x. So 4 into x, x is given as 1 by 3. Okay, so now it is simple. 9 upon 1 plus, that is 1 upon 4 by 3, that is 3 by 4, right? So this will be 7 by 4, 7 by 4, so 36 by 4 into 1, 4 1 4 plus 3, 4, 7 by 4. So 4, 36 by 7. So we are getting m as, m is equal to 36 by 7. Okay, we got m as 36 by 7. Okay, is it or not? Simple enough. Okay, so if we are getting 36 upon 7, so this will be 5.1 something. Okay, this will be 5.1 something. So here we are getting m is equal to 5 point something. That is, m does not belongs to the set of integers. If it is not an integer, the case is r will be lying between m minus 1 and m. So here in this case, 5.1 minus 1, that will be 4.1 and 5.1. So r here, r we are getting, that is 5. So if r is equal to 5, then hence we can say the numerically greatest term is tr plus 1, that is t5 plus 1, that is t6. Okay, so t6 is your numerically greatest term. Is that clear to everyone, guys? t6 is your numerically greatest term. Clear? Understood to all of you guys? Now it is clear. Now next question for your homework. Okay, this question as your homework questions, you can take a screenshot and also you can note it down also. Okay, so previous question is clear now. Okay, next question is find the numerically greatest term in the expansion 3 plus 2x whole to the power 50 when x is equal to 1 upon 5, right? Okay, and previous question is clear. M, first find out m. After finding m, if you are getting m is integer, you will get 2 numerically greatest term. If you are getting m is not an integer, you will be getting 1 numerically greatest term. Okay, so now it's more time. Actually, we have taken 15 minutes more. Thank you all. Thanks for your patience. Thank you. Chalo, bye bye. Take care, everyone. That's all for today's class. In next class, we'll start application of binomial expansion, right? In the next class, we'll start from application of binomial expansion and we'll be solving some previous questions. Bye bye. Take care, everyone. Thank you.